This is me explaining why the moon looks different on the northern hemisphere and the southern hemisphere on a flat Earth. All right, real quick, before I get into this, I have to give you some sort of backstory. So a lot of globe earthers will use this proof to disprove the flat Earth. They will say, well, you can't possibly have people in the southern hemisphere and the northern hemisphere see different sides of the moon unless they are upside down relative to each other. Like, I'll show you. Let me do a quick demonstration. Here is a globe Earth, all right? We have somebody up here in Russia, very, very, very top of the Earth, okay? And then we have someone down here in Australia, okay? So two people on opposite hemispheres. This here is the moon. If I put the moon here, the people up here are going to see a different angle of the moon than the people who are upside down relative to the people on the opposite hemisphere. Now, people use this all the time as something that debunks flat Earth because there's no possibility that you could see different angles of the moon unless you are upside down relative to what hemisphere you're on. But I'm about to show you that that's not actually the case. In fact, this doesn't prove either the globe Earth model or the flat Earth model. It just shows that it works on either one. But before I show you why and how that works, I have to explain to you what the flat Earth model even is. A lot of people believe that the flat Earth is just a floating disk out in space and the sun is still a big flaming giant gas ball and the moon is still a rock that reflects the sunlight, which is not the case in a flat Earth model. So that's what I'm about to show you right now. Now, here is a demonstration with the flat Earth model. I know this is really tiny. I'm working with what I got here. So, the flat Earth model is basically a flat, obviously not completely flat, there's obviously mountains and stuff, but a flat kind of disk where Antarctica is on the outside and there is a firmament or dome above it. So the North Pole is here, Antarctica is around here, the equator is about right here. So this technically is the northern hemisphere and this out here is the southern hemisphere. So that's the basic layout of the flat Earth model. And it is not floating in space, it is floating in the waters, just like the Bible says, separating the waters from the waters. So there is water above the firmament, which is this dome here. Now, the flat Earth model says that inside this dome, either actually physically touching the dome or below the dome, there are the sun, the moon, and the stars. So let's take off this dome for a second. The sun and the moon are small and localized, which basically means the sun and the moon are like two dots that would be rotating around this. The moon and the sun are rotating around in cycles and the seasons work in a certain way, and that'll be a completely different video, but that is how the flat Earth model works. So here we have our flat Earth model. Let's say the moon rotates and it is currently right in between North and South America. Now let's say that there was someone in South America. How would they see the moon? This is how we would see the moon in South America. Now, let's say we wanted to move to the other side of the moon, to North America. How would it look like then? So, we would walk across and go to the other side of the moon, which is North America. Now, how would the moon look to us? This is how the moon looks like. So yes, in the different hemispheres, quote unquote, you do see different angles of the moon, but this does not necessarily mean it's because it's around Earth. It also works on the flat Earth model.